Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ogobela Wemet. And without any further ado, let's look at these questions that we have here. Okay, so we have energy principle activities. We have question 5 here. A 20 kg box is pulled from rest as shown in the diagram below across a rough floor. So it's telling you that the V initial is 0, and then again it's moving across a rough floor, so meaning there is frictional force. Then just down below the diagram here, they mention the frictional force. They say the frictional force between the box and the surface is 20 newtons. So one thing you always have to be considerate of, always read all the statements there, whether they appear above the diagram or below the diagram. Then they say neglect the effect of air resistance. Right, 5.1 says classify frictional force as a conservative force or a non-conservative force. Now we already know that frictional force is a non-conservative force. So we're going to say non-conservative force, right? So this is the force for which the work done in moving an object between 2 points depends on the part taken, right? So this is non-conservative. Then 5.2 says draw a labeled free body diagram for the box whilst in motion, right? So we want to start with our gravitational force going downward like that, and then up there we have our normal force, and then this is being pulled at an angle, so this will be our force applied. Then you can show the angle if you want, or you just leave it like that. And then opposing the motion will be our kinetic frictional force. So when they mark 4 forces, right? So that's your FA, your FN, your FG, and your kinetic frictional force. And that's how you have it, 4 marks, 4 forces. Now, if you choose to resolve your force applied to Fx and Fy, that is also not a problem. Then 5.3 says, write down the work energy theorem in words. Okay, so work energy theorem states that the net work done on an object is equal to the object's change in kinetic energy. That's how you're expected to define it for 2 marks. Right, then let's go to 5.4. So 5.4 is saying use the theorem, meaning use the work energy theorem, in question 5.3 above to calculate the momentum of the box after it has been displaced for 5 meters. Now, this is a 5-mark question, and then we know with the 5-mark question, it's usually a case whereby we have to apply more than one formula. So we are looking for a particular quantity, but then there's something that's stopping us from getting it. So now if we can just go ahead and write the formula for momentum, we know that momentum is the product of the mass of the object and its velocity. But then right now, in order to calculate the momentum, we do understand that we need the mass, which we are given, that's 20 kg, but we also need the velocity, right? Obviously, we want the velocity of the box after it has been displaced for 5 meters. So we cannot be using this velocity initial here, because this is before it was displaced for 5 meters. Now, that means, what are we going to do here? We do understand that we must find the momentum, but first we need to figure out what is the velocity. So now you understand how we approach that 5-mark question. So we first find the velocity, and then we can then find our momentum, right? Now the theorem that we are told to use is the work done by, is the work energy theorem, meant to say. So that means W net is equals to change in EK. Now we do understand that if we have to break down our change in EK here to half mVF squared minus VI squared, the velocity that we are actually looking for will be the V final. Right, now let's go ahead. From our free body diagram, we saw that the only air forces that will be doing work would be the force applied, which is acted at an angle of 60 degrees, and also the kinetic frictional force that was opposing the motion. So our W net will be represented by work done by force applied plus work done by frictional force. Now, we do understand that there's normal force and gravitational force, but those two are not doing any work due to the fact that they are perpendicular to the displacement. So if the angle between the force and the displacement is 90 degrees, meaning when the displacement and the force are perpendicular like this, so that was your normal force. But looking at your displacement, it's moving like this. So the angle between the force and the displacement is 90 degrees. No work done. So here there is no work done, which is why we are not even considering to put the work done by normal force and also as well the work done by Fg into the W net formula, because they will just be zero. Right. So now we are left with work done by force applied plus work done by Fk. These are the ones that are doing work on the object. Now, this is equals to change in Ek. Let's now break down everything. So if we have to break down our work done by force applied, this breaks down to what? It's the force applied multiplied by delta x and then cos theta, right? So remember, what is work? It's the product of the force and the displacement, right? And then also along with the angle between that force and displacement. Then this is equals to Fk delta x plus, Fk delta x cos theta is equals to half m Vf squared minus Vi squared. So now we've broken down everything. Now it's just a matter of putting in your values. So what is our force applied? We've been given here that it is 100 Newton. That's shown here. And then that's 100. But then they said this block is displaced for 5 meters. And then that's cos. Now, if we have to consider the angle between the displacement and the force, we can see that this is our displacement moving along like that, but then our force is being acted at an angle like this, meaning the angle between the displacement and the force in question now is that 60 degrees. So here we have to substitute 60 degrees. And then this is Fk, our kinetic frictional force we've been told is 20 newtons. So that's 20. And then now we have 5, and then cos, the angle theta is 180 degrees, because again, if we look at the displacement versus our Fk, we can see that they form an angle on a straight line, which will be 180 degrees, right? Always note that whenever we are substituting cos theta for Fk, it is always 180 degrees, because this force here, kinetic frictional force, is always opposing the motion or the displacement of an object, right? Then at this point, we need to substitute this part. So allow me to just say equal here. And then this is half. Our mass is 20. Our final velocity, that's what we are looking for. Then our initial velocity at rest, that's 0. If we punch all this here up here, this gives us 150. And then equal to, what is half of 20? That's 10. And then multiplied by, remember, Vf squared minus 0 is just Vf squared. So that's Vf squared, right? Then at this point, we divide both sides by 10. So our Vf squared is equals to 15. And then to find our answer, we need to square both sides like that. Then our final velocity is 3.87 meters per second, right? So I just rounded off to 2 decimal places. But then remember, this is not the end of the question. We then go back here. Remember, the question was asking us to calculate the momentum. So let's not get carried away with the question. We still need the momentum. So we were calculating the velocity because we did not have the velocity in order for us to calculate the momentum. Now that we have the velocity, that's when we go back and calculate the momentum by saying P is equals to M times V. And then our mass is 20 multiplied by our velocity of 3.87. And then our momentum is equals to 77.4 kg meters per second. Remember, it's momentum. The SI unit for momentum is kg meters per second. Right. And that's how you could have got that 5 marks. So please play this video as many times as possible and try to understand the approach that I took in answering this question. But with all that being said, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And more importantly, please share the link with your friends and classmates so that they may also find assistance. And also don't forget to hit that subscribe button. I almost forgot that.